Friday lesson with Mr. B. So this lesson is going to take you the next week to complete. So including today, I'm not going to be making a new post for you guys until next Friday. I believe that's the 27th, give or take, or might be closer to the end of May. However, you will have Friday, Monday, and Wednesday. I will not be making any new posts until next Friday. So you have almost a full week to complete these different experiments. Now, this whole unit, this whole topic is four activities. We're only going to be doing three of the activities because one of them we don't have the equipment for, or I would assume you don't have it at home. So we're just going to cut that one off, and we're only going to be focusing on these three. Again, any activities that you're not able to do at home, don't worry about it. We'll go over some of the stuff that you could expect to see from it, and it's just a good refresher on the material that we just covered in the last week or so. You can work through these activities in any order that you want. I'll start by explaining activity one and what you're going to be needing to do for each activity. So with activity one, it says you're doing it in partners or in groups. Obviously, you're going to be doing it on your own. Nothing is so crazy that you need to do it in a partner or with another person. It's just if we were to do this in class, we'd be doing it in smaller groups. For you, you get to do it all on your own for these three activities. So as it says right here, the purpose is, along with examining forces, at this station you'll be looking at your ability to collaborate and hold a discussion based on scientific topics and concepts. Some of this stuff we'll be skipping over, but what you will need is, if you have a bike, it's awesome. You can go and do a hands-on look at it using these kind of guiding questions to figure out what you need to. Otherwise, you can just use the image of the bike right here, and you'll still be able to work through the activity itself. Blank piece of paper, pen or a pencil, and then you're ready to go. So it says to set up a data table similar to the one shown below to record your observations for the 5 parts of the bicycle. So down here, it shows you the observations and what you can do with your data table. So the name of the part, which it has for you right up here. The letter, in that case, the letter is referring to the letter that it's labeled by. So A, B, C, D, and E. What causes the force, so based on the reading, so based on the part, what causes the force in the bike, and what type of strength does that part of the bike need to resist. So again, earlier this week we talked about our 4 forces being compression, tension, torsion, and shear, as well as those type of strengths. So compression strength, tensile strength, torsion strength, and then shear strength. So what you're going to be doing, you'll give your data table a title, so maybe bike parts or forces on a bike, whatever you want to call it is fine. And then you're going to use the diagram or your bike in real life to fill out the data table based on the descriptions. So if we were to do one of these as an example together, the spokes would be the part name, so we'd put spokes. That is letter A. Now, what causes the force? Well, we have to read through here. So the spokes are stretched slightly by the weight of the rider. So what causes the force? It would be the weight of the rider, and that would be causing a tension force because the spoke is being stretched, and we know that a stretching motion is a tension force is being applied to the spokes, and that's from the weight of the rider. What type of strength is needed? Well, if we have tension force, so the spokes are being pulled apart, those spokes need to have very strong tensile strength. If they didn't have good tensile strength, then the weight of the rider would cause those spokes to snap, and then your bike would not be very useful to you for future rides because you don't have any spokes anymore. Then we would go through the same process for B. So the seat position, the seat post, so that's this part right here, not the seat itself, but the part holding up the seat. And again, it's being pressed down on by the rider's weight. So if the seat is like this, you're pushing down on it like that. What force is being caused? So like what type of force is that? And what type of strength does the seat post need in order to resist the force being applied to it? I'll let you guys work on that one on your own because we did A as an example, so I won't give you too many answers. As you scroll down here, these would normally be discussion questions that we would engage with in our group in class. For you, you can just answer them on your own and on a sheet of paper, on the same sheet of paper that you've done the data table on. So True or false? Only one force can act on any one part of a structure at a time. So that's basically saying if a structure already has compression force on it, then no other force can be applied to that. You can't twist it at the same time. You can't stretch it at the same time. There's only one force that can be applied to any structure at any given time. And whether or not you think that is true or whether or not you think that is false. Again, not necessarily a right or wrong answer, but just a discussion that we could have in class. But in this case, you can just pick a decision, true or false, and then explain why you feel that way. And then for number 2, if you would like to, as like a bonus, you can identify 4 additional parts, or 1 or 2 or 3, of the bicycle that might fail because it has too little of these type of strengths. So if up here we have our tire, our handlebars, our spokes, our seat post, and our pedal bolt, so what's basically holding the pedal onto the bike, we would pick a different part. So if we want to say maybe the brakes and what type of force the brake has to endure, whether that's tension, torsion, compression, or shear, what type of force is being applied when you have to hit the brakes, and what type of strength do those brakes need to have. If they didn't have enough of this strength, they would break. What type of strength would they need? Again, that's more of a bonus one. You don't have to do that. But you could, if you have the time or you want to challenge yourself a little bit by coming up with a part of the bike that's not labeled and what force it has to be able to resist, what type of strength that it needs. So that's activity number 1. So just 2 additional discussion questions as well as filling out the data table. For activity number 2, you are going to need a blank piece of paper, a pen or a pencil, a bendy straw, and a popsicle stick. Again, if you don't have both of them, you can just do the experiment with one and you'll just miss some of the information by not having the other one, but it's not a huge deal. The safety goggles are more needed with the popsicle stick, but again, they're not 100% necessary. And neither is a magnifying glass. If you have one, great, you can get a more in-depth look, but it's not necessary in order to conduct this experiment. So once again, you're going to be making a data table with 4 sections to it. So 1, 2, 3, 4. Taking up at least half the page, similar to one on the back of this page. So again, if you just want to use this one, that's great. Again, it says actual table should be larger. If you can write in that box or draw in that box, that's fine. If you want to redo it, that's fine. Or you can just use this one as you need. So you're going to give your data table a title, and then you're going to start by placing the unbent straw on your table and draw the pleated section. So the pleated section is the stretchy part of the straw. So that little like ridged area in the middle that you can extend the straw or bend it, that is the, what do they call it? That is your pleated section or your bent up section. So you're going to do like a zoomed in image of what it looks like before you've bent the straw in any way. So prior to this, your straw should be straight and not have any bends in the straw. And then you're going to draw what it looks like and then label it as compression. So one of these 4 quadrants is going to be the straw, unbent, and then you're going to label it compression. What you're going to do next in another quadrant is you're going to gently stretch the straw. So now you're extending that bendy straw so that it's those little ridges are all stretched out. So you're making your straw as tall as possible. And then you're going to draw a detailed drawing of what that looks like in the top right. And again, that you're going to label that one tension because we had to pull that straw apart in order to get it to the side. So we're applying a tension force to the bendy straw. You're going to draw what the bendy straw looks like after that. What you're going to do in this bottom quadrant here is you're going to bend that straw as if you were drinking it. So you're going to bend it down. And then what you're going to do is you're going to draw it in detail and then label that tension and compression because part of that movement is you're applying some tension to the straw and you're also applying some compression. So which side of the straw is each force? And then you're going to draw a label diagram of that. So the last one, if you're able to, in the bottom corner here, is you're going to now take the popsicle stick, if you had it available to you, and you're going to put your thumbs underneath it like this, and you're going to push up on it, basically trying to break that popsicle stick down the middle, or to see it break. So you're going to apply enough force with your thumbs pushing up that the straw, that the stick snaps. Once it just starts to break, so don't snap it all the way, slowly apply that force so you do it just enough so it just starts to break. And then you're going to use the magnifying glass to observe the broken part of the straw to see what that looks like. So again, drawing in detail what that middle section, so that broken section of the straw looks like, and then label where the tension and compression occurred. So basically you're looking at different examples of compression force and its application as well as tension force and its application. Once again, just a couple of questions here. Again, answering them if you would like. The main part that I want to see from this experiment is the data table. So the discussion questions are bonus. You don't have to answer them if you don't want to, but I want to see the discussion, the observation charts and graphs done. So I want to see your drawings, but I don't necessarily need you to answer these discussion questions. If you would like to, fantastic, but they are not required. Finally, activity number 3, the last one that you're required to do, because the fourth one we're not even going to go over because it's more than what you need and you may not have the materials at home. So you're going to need another blank sheet of paper, a writing implement, pen or a pencil, a washcloth, so that's like a dish rag or like a small towel like that, a bucket. A graduated cylinder is not necessary. You can just use a measuring cup that you would have at home. Again, a funnel is also not necessary. It helps to bring all of the water together, but it's not necessary as long as you're doing it over a sink or in a bathtub. And then towels. So again, like a washcloth and a towel, those are like just different size towels, essentially. Again, you're going to make a data table. So here is your data table right here. It's the method that you used, which we'll talk about what that means in a second. The amount of water, so that's where the measuring cup comes in handy, and the type of force that you applied. So what you're doing is you're going to put the washcloth into a bucket of water, and it's going to absorb all the water that it can just by sitting in there. Then what you're going to do is while holding it over a bucket, you're going to squeeze as much water as you can out of that towel into an empty bucket. So without twisting it like you normally would to wring out water, so without using torsion force, you're going to try and get as much water out of that towel as you can. So you're going to absorb water in one bucket, you're going to pick it up, take it to an empty bucket, squeeze out the water in however you want without doing that twisting torsion motion, and then you're going to pour that water that you were able to squeeze out of it into the measuring cup so you can see how much water you were able to get out of the towel without doing that torsion twisting motion. You're going to do that multiple times, and you're basically going to try a bunch of different strategies in removing as much water as you can from the towel. So that's where the method comes in. So did you squish it? Did you shake it? Did you bend it back and forth like this? How did you go about removing the water? How much water were you able to remove? And what type of force were you able to apply? Did you apply a compression force? Did you apply a tension force? Did you combine forces? Did you do like a tension compression combo kind of thing? What type of force did you apply to it? Once again, these are these optional discussion questions. You don't have to do them. So what type of force are you applying in each situation? You're going to record your answer in the data table. And how does the amount of water removed relate to the reduction in the space in the substance? Again, these are optional questions, so if you want to attempt them, by all means, go for it. My main concern is that I'm seeing your observations get complete. So those are the 3 different activities that you are going to be doing over the next week of time. I will post another video on next Friday with your next lesson, but this should keep you busy for the next week or so. So don't come back on Monday and Wednesday looking for lessons. This is what you guys should be working on so you can space it out over the next week or so. So you can do one activity every couple of days and you'll be covered. I'm not going to be overloading you with other information. If you have any questions, let me know. I'm just an email away, and we can figure out if you're having any problems with the discussion questions or the setting up the activity or just want clarification. Feel free to send me an email. I hope you guys have a good weekend, and I will see you next Friday.